Dear students, let's start lecture number 11 on the topic Steganography, part 2 of the course Network Security. And this is our outline. First of all, I'll revise lecture number 10. Then I'll take another example of steganography in images. If you remember, in the last lecture, I have given you one of the examples of steganography. So today I'll be taking one more example that is called least significant bit technique, and then stag analysis. I'll be explaining stag analysis and important aspect of stag analysis. Then uh, application of a steganography, and then advantages and disadvantages of steganography. So let's start with the revision of lecture number 10, which was on the topic steganography part 1. So there are certain terms which you need to know uh, uh, before understanding this lecture. So carrier or cover file, original message or a file in which the hidden message will be stored, we call it as a carrier or cover file. Then stago medium, the medium in which the information is hidden, we call it stago medium. Embedded or payload, the information which is to be hidden or concealed, we call it as embedded or payload. Stag analysis, the process of detecting hiding information inside a file. Now, steganography, what the steganography is, it comes from Greek word. It means covered or secret writing. Stagno means covered and graphic means writing. So we call it as a covered writing, hiding one place of data within another. The goal of a steganography is to hide the information so that no one apart from the intended recipient knows that a message has been sent. This can be achieved by concealing the existence of the information within seemingly harmless carrier or a cover. This is a block diagram of steganography. Like you need secret message which you want to send to the recipient, and cover image in which that secret message would be placed using this embedded algorithm, and then key will be generated, and that key will be sent to the decoding or extracting mechanism. And this stego image will be sent over insecure communication channel, and when it reaches the receiver will be using that stereo key and stego image to get the secret message back. This is how the operation is performed. This is somehow different from cryptography, where encryption is performed. Like in cryptography, your message is scrambled in such a way that is converted into cipher form, if you remember. But in this type of secret writing, you need not to perform any kind of encryption. You will just hide your information inside some other information, so that if it received by the intended intruder or a malicious user, he will not able to get the meaning of that what you want to send to the receiver. Now, types of steganography. So, steganography can be applied to text, images, audios, videos, and protocols. If you remember, I have given you example in the text, like how it is performed in text. You can see here that, for example, if a sender wants to send this text to the receiver, so what the sender does, that it takes the first letter of each word. Like you can see here, I have highlighted them with the red color. So they are combined, and secret inside is this is the text which is created, and now this will be sent to the receiver, and then receiver knows that what is the meaning behind this information. But if it is received by some intruder, he will not be able to get the meaning of that what sender wants to send to the receiver. Now, this is German. This is a cipher text by German spy in World War II, which was sent. You can see here. This is a text, and the science is that taking a second letter in each word, and this will be created like Pershing sail from NY June 1. So this will be created. If you have this science, you can using this key or a science, you can extract your meaning from this text. So this is how steganography works in text. Now, this is a third example. Like if this is a text, you can see again first letter of each word. This has been taken, and this secret message will be sent to the receiver. And if this message is received by the intruder or somebody else, he will not be able to get the meaning of that. Now, stenography in images, we have considered first example of like what that image practice of concealing secret message in digital images. You know that if you want to send something to the receiver, what we do that we will put our information in that digital image and send to the receiver. And that if that information is received by the intruder or a malicious user, he will not able to recognize where the information or what the information is stored inside that information. Two very simple way messages can be hidden in digital messages. These are the techniques like JPEG concealing and least significant bit technique. So what was JPEG concealing? If you remember that this is the journal format of the image. That image starts with the start of image and ends with end of images like EOI. So between these two markers, normally image interpreters knows that information reside only between these two markers. So anything next to these markers, that interpreter consider interpreters do not consider, and they are ignored automatically. Now you can see here that this is the standard of the image. Like you have a start of image and you have end of images, and this is the hidden information which I want to send to the receiver. So what I do that I'll piggyback my hidden information with this image. So this will travel with the image wherever it goes. So where the image goes, this my hidden information will be traveling with that image. So normally the interpreters, interpreters they do not consider information next to EOI. So but if you want to store more information, so this might arouse a suspicion, yeah, that you have to be wary of that intruder might get this reflection that as your size of the image is size of the image is larger, so he can get this intention that there are some hidden information inside that image. So there is a trick that you normally it is used by that you can increase the resolution of JPEG file to turn the attention away from the hidden message. So that is how we will send our hidden information with the image files. Now, lecture number 10 on the topic steganography part 2. Now, this is second example. Like we have taken one example on JPEG concealing, and now this is a second example which is called least significant bit technique. So what this technique says, that the least significant bit is a very slave way of hiding data in images, taking advantages of the fact that the small changes in pixel colors are invisible to naked eye. As you know, that if you make a little change, like a change of 1 or 2 bit, it cannot be visible to the naked eye. Encoding images in red, green, blue, each pixel color represented by a combination of certain amount of red. As you know that each pixel you have a certain amount of red, you have a certain amount of green, and a certain amount of blue. The amount of red, blue, green, red, green, blue is given in the range 0 to 255. I think you know that. Pure R would be represented as 25500, as there is no blue, no green and no blue, all are red. So if I represent this red in pixels or in a bits, so this will be R will be 111. As you know that each character in ASCII is represented with a 8 bit. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 bit are, so all these are 1, and there is no green and there is no blue in that. So what about if we change 1 bit in that? For example, if I change this 1111 to 1110, any difference? So this cannot be visible with naked eye. And what about if we change 2 bits? Again, this will not be visible with the naked eye. So you can adjust your information inside those digital images. So intruder will not be able to get the meaning of that. For example, if the sender wants to send SOS, this is the information which the sender wants to send to the receiver. So what we do, that we will convert uh, each letter with their corresponding bits. Like S will be represented with 0, 1, 0, 1, 0, 0, 1, 1. O will be represented with 0, 1, 0, 0, 1, 1, 1, 1. S, again this is represented with 0, 1, 0, 1, 0, 0, and 1, 1. So split each bit into 2-bit pair, like I have split it here. So S has the following 4 pairs like this, and um, spread these pair successfully along multiple pixels. Like for example, you can see here that multiple pixel I am sending my S information, as S is represented with 2-bit pair each. So you can see here that I have a 3 pixels, one for red and green and blue. So I have changed, like S is 0, 1. You can see here 0, 1, 0, 1, and 0, 0, and on the another pixel I have placed 1, 1, and this way I can place all my bits in their corresponding pixels. So then this information will be sent over the network. So spread these pairs successfully along these pixels. So if our image had 4 pixels, each would be encoded like this, each letter spread across 2 pixels. 1 pixel encodes the first 3 pairs, and the next pixel takes the last pair. As you know that we have only 3 pixels. So in each pixel I have adjusted 2 bit of S, and 2 bits are still remaining. So I'll adjust these 2 bits in my next pixel. So this way I'll adjust all my information and send to the receiver. Note, choose to use more than 2 bit per pixel to store messages, but remember, by using more bit risk changes to each pixel becoming perceptible. So this way, this depends on your information, what you want to send. So by using that, you can adjust your each letter decimal value on each pixel and send with the with those pixels. So normally it will not be visible to the naked eye, and if the intruder or the malicious user observe that color, for example, if the malicious user get this red, so he will not be able with these changes of 2 bits, are not so visible. So the color of the red will remain red, black will remain black. So this will not be visible with the naked eye, and the intruder will not be able to get the information that what the sender wants to send to the receiver. Now, stegoanalysis is the art and science of detecting a secure communication. Hiding a message will most likely leave detectable traces in the cover medium. The information hiding process changing the statistical properties of the color, which is stegoanalysis attempt to detect. So, stegoanalysis detect the traces, and using those traces, he will get the he will try to get the information that where the information is stored inside that data or information. The process of attempting to detect statistical traces is called statistical Steganalysis. Like for example, you can see here that cover image and hidden message, when they are combined and sent, and stego image is created, this is called stenography. And when you have a stego image and you will want to detect the hidden message inside it, this is called Steganalysis. So Steganalysis needs a lot of experience, and there are tools which helps you to know that what sender wants to send to the receiver. Now, important aspect of Steganalysis, there are two important concerns of Steganalysis. Detecting hidden information, that where information is hidden inside of that broad information, and disabling steganography. So if he disables steganography, so he will get the hidden information inside it. These are the applications performing confidential communication. Normally it is used, steganography is used for performing confidential communication, storing data, secret data inside of that information or data. Protection of data alterations. Normally it protects steganography. Steganography protects the alteration of data, because normally normally intruder or malicious user will not be able to detect where the information is actually stored. Access control system for digital content distribution and media database system. So these are the applications of steganography. Now, advantages and disadvantages of steganography. So advantages are difficult to detect. Only receiver can detect where the information is stored inside that image, text, or audio or video, and can be done faster. This can be recognized. This can be recognized very faster by using a large number of softwares, providing better security as compared to cryptography. If you remember, in cryptography, user can get the ciphertext, and by getting that ciphertext, he apply different kind of mechanism and patterns to get the secret message. But in this case, the intruder or malicious user unaware of that where the information is actually stored. So the first thing would be for the crypto analyst, sorry, for the stego analysis to detect where actually information is stored. So once he reaches the information, then he will. This is another question to get the get that secret message, and then applies to know that what sender wants to send to the receiver. Now, disadvantages: the confidentiality is maintained by the algorithm. Algorithm is known, then the technique is no use. So if the algorithm is known to the stego analysis, so he will get the algorithm. If he get the algorithm, the technique is of no use. Password leakage may occur, leads to unauthorized access of data. If technique is ignored in the wrong, if the technique is gone in the wrong hands, like cracker or a hacker, can be very dangerous for all. For if he knows the algorithm or the technique which is used by the sender, so he will get all the information and can give a lot of harm to your system. Now, these are the sources which I have cited. You please go through them and find out more about this topic. So, uh, with that, it reaches to end of this lecture. So, if you have any question, you can ask me through KCMS, WhatsApp, or you can email me. I'll be more than happy to answer your question. So, in the next lecture, I'll be continuing this lecture with part number 3 of steganography. So I'll be explaining more about the differences between steganography and cryptography, and then we will try to combine steganography and cryptography, and then we will be explaining differences between watermarking and steganography. So the next lecture will be more interesting. So till then, Allah Hafiz.